everyone, welcome to qconbridge. Today I'm going to teach you to draw the shear and moment envelopes. So here is an example. The bridge is of two spans, each 120 feet, and in here I have calculated the envelopes for shear and moment for WDC1, DC2 and DW. So what are these terms? DC1, DCW, DC2 and DW. So DC is the dead load of DC2 is the dead load of non-structural components, for example barrier, right? So you have to calculate these things manually. For example, DC1 is the dead load of the structural components, so it may be girders, slabs or any other things. So you need to calculate these things by yourself. So we need to calculate DC1, DC2 and future wearing course DW. So now what we are going to do is like for each loads DC1, DC2 and DW, we are going to find these values of coordinates of envelopes for shear and moment at different positions. So this is then we are going to calculate HL93. So you must know HL93 if you are studying bridge. And for different load cases, like for service load or service 1, service 2, strength 1, then you can calculate the envelopes. What is envelope? Envelope is basically a width beyond which these terms are not going to exceed in any of the cases that will occur in a real bridge. So there are basically two methods of analysis, and the first method is more manual and it is easy to understand the how qcon works, and the second method, it's very simple and you can do it in like 10 to 15 minutes once you get it. So in the first method, what we do is like it is called undistributed unfactored method. We get undistributed unfactored values from qcon, then we make them factored distributed values by ourselves in Excel by doing multiplying each rows of undistributed unfactored values by some factors, some distribution factors. So it is kind of manual. Okay. The other method will be like inserting the distribution factors and load factors by ourselves, and then the qcon will do all the analysis, or it will give you the final results. So first of all, I will just teach you the basic method, and if you can do the basic method, then you can easily understand the other one. So I will show you an example of two-span bridge of length, each of length 120 and 120 feet. In here we have to put the section properties, but I'm doing the calculations of dead load by myself, so I'm not going to put any of the section properties here. And the second part, you can see that it is for the distribution factors, and it asks for a service or strength limit states. So for that we have to do the calculations manually, and to do the calculations here you can see that we have to calculate the modular ratio, and we have to do these calculations as shown here, and they are all based on the AS to LRFT code. So if you want to know more about it, you can use a book by Barker as reference, or you can just go over LRFT code by yourself. So for interior girder moment, if it is one design lane loaded, then there is the formula for the distribution factor for single lane load as given as shown here. Similarly, for the multiple design lane loaded case, you can calculate the distribution factor, and then you take the maximum of them is the distribution factor for moment. And likewise, we have to calculate the distribution factor for shear for both one and multiple loaded case. Then you have to pick the maximum of both of them as the distribution factor for shear. But remember, in the first method we are dealing with undistributed unfactored load method, so we are not going to put these distribution factors in qcon. Instead we will do these things manually. In the second method, I will show you by direct inputting the distribution factor, we can calculate the results directly from qcon. Okay. Also, don't forget to calculate the distribution factor for fatigue manually as shown in the figure. Once you see the reference book or code, you can easily get a way to calculate these values, so it's not a big deal. Thus, for our first method of analysis, I will just leave these factors as they are, and I won't edit them. But in the second method, I will show you to put the calculated distribution factors and do the calculation. So now my first load will be DC1, so its value is 1.589 kip per feet. So let's put this load in my first span. So select the span, then go to load and add uniform load. So the unit is given in pounds per feet, so you should be aware of the units. So what I will put is 1589 pound per feet because it was 1.589 kip per feet. Okay. Yep. And then the load is on both spans, so click on all spans. So load case is DC, and that's fine. So here I won't be describing all the inputs in this box because I'm assuming that you have watched my previous videos and you have the basic ideas about what the fraction or this start in the value of start 0 and end 1 means. So I will just skip that part. So now analyze the beam by putting some numbers of analysis points. So let's make it odd because if it is odd, we can access the midpoint of the beam. Okay, so let's make it 11 and then click on OK. So the analysis is successful. Then let's go for bending moment diagram or shear force diagram. Okay, so our load is in DC load, then click on OK, and this is our shear force diagram. To generate the table, go to view and click on tabular results, and then right click, select the load, DC load, and then click on OK, and this is our table value.
These values of from qcon won't match with the values in this table shown in Word file because the table in Word file is obtained by considering as a single span bridge.
So to draw the bending moment diagram, we can do similar to this, and this is the BMD, and to change the invert the moment diagram, you can work like that. And to generate the table, select load, and then click on OK. And here you can see that the shear and moment values are given in the table. So you can generate it, export it to the text file, and from there you can export it to Excel, and then you can draw your own diagrams if you are not going to use the ready-made files from the qcon. Now listen carefully. Now you have to do the similar calculations for other loads DC2 and DW and find the envelopes for shear and moment similar to DC1. Okay, so I'm not going to do it because it will take lots of time and it's a similar process, so I think you can do it by your own. So after calculating those envelopes, you have to calculate HL93, and for HL93 you have to calculate the shear and moment. Okay, so you have to find the range of minimum to maximum for shear and moment is shown in this table. So then after then you have to calculate for load combination service 1, service 2, or strength or fatigue, each per is your demand. So you can get these load factors from Astral RFD. So now I will show you my reference book that I'm using, Barker's bridge design book as my reference book, and here you can see the load combinations and load factors for different load combinations for strength 1 limit states. You can see that DC, DW, right, live load, they have different load factors. And gamma P, I will show you another table where gamma P ranges from a particular value, small value, to a larger value. Okay, so and the load factors for each limit state is given, and here you can see that the gamma p values lies from maximum to minimum range, so it is kind of a range. So these load factors are given by Astro LRFD. So you can look into the book and can gain more knowledge about the limit states and the load factors they are using. Also, you can even find the reasons why they use these particular values and why these load factors vary from one to another. Okay. Also, you need to calculate the load modification factors for each limit states, and like these are also given in the reference book or code, so you can also find the reasons why we use them, and also you have to calculate it for impact loads. And it is also, yeah, as I mentioned every time, that the reference book is very very important if you are going to be successful in bridge design. Okay, then we are done. Now we'll plot these values in Excel and see the envelopes and compare the shapes with the shapes in the report. So this method seems quite lengthy, but this method is very basic. Once you understand it, you can understand every other method. So in the second part, I will deal with the easier method, distributed and vectored method. So please watch another video and please subscribe my channel, and thank you very much.